What is the mic period?
Huh?
The sound.
It is plugged in. Hopefully everything will work this time. We have the area of a triangle that we're trying to find, and I've given A is 42.7, C is 64.1, and my beta is 74.2 degrees. So what I did was I sketch out a rough triangle, and I realize I have side angle side. Then I write down my area equals the 1/2, 42.7 times 64.1 times the sine of the included angle, 74.2. Put it into my calculator, and 1317 units squared. Make sure your calculator mode is in degrees.
Are we ever going to be in radians this section?
Not this section. No, we're going to jump to vectors next, but not.
It's an aggressive word. Vector.
We're off this only.
Yes, vector.
All right. So moving on, when you're given the information, look at what they have given you. So we have gamma is 98.6, beta is 32.4, and alpha is 24.2. How do I know if these are angles or if they are sides?
Well, because of the letter in front of them.
Yeah. This does not have degrees, but gamma and beta are going to be the angles in question. So when I'm drawing it, then I have an angle, the side included, and an angle. And to use my area formula, I need side, angle, side, or side, side, side. What can I use if I have angle, side, angle? Law of sines from the very first section. Then I can either find a C or B, and it does not matter which one you solve for. I just chose C. C over sine of 98.6 degrees equals 24.2 over sine of 49. How did I get 49? Any triangle has 180 degrees, so 180 minus 98.6 minus the 32.4 gives me the 49. Now I can use my formula because I have been given a side angle side. 1/2 of the 24.2 times 31.7 times the sine of the included angle, 32.4, gives me my 205 units squared. An area is units squared if they don't give you a unit, right? Or if it's feet, feet squared, yards squared. Am I going too fast? Little, just a smidge. Question.
How are we supposed to enter the law of sines into the calculator? Because sometimes when I do it, I just get the wrong thing.
Okay, to enter in the calculator, I check to make sure that my calculator's mode is in degrees because my angles are in degrees. I am solving this triangle. You can cross multiply and divide, or you can divide and multiply. It's just depending on how you want to do that. When you are cross multiplying and dividing, I typically put the 24.2 in front of the sine of 98.6. If you don't close your parentheses, it will give you the wrong answer. 24.2 times the sine of 98.6, close my parenthesis, divided by the sine of 49. And that gave me the 31.7. Okay, so you can do it either way. Any other questions before we move on? When you look at this problem, what do you see?
I see two triangles.
Okay, you can draw this diagonal and have your two triangles. And then you have this base times this height divided by 2. You then could use the Pythagorean theorem to find the 4.9 yards to get your diagonal. We have this side, and then we're going to have to do some trig to figure that out. When I look at that and I need to find the area of this figure, I drop down the perpendicular and make this a rectangle, which means I need this entire length. If I don't put the diagonal in here, this angle is 180 degrees, the straight angle. So this little angle that I've just drawn is 80 degrees. If I drop the perpendicular, then this is a 10-degree angle, and I need this side. Opposite over adjacent is the tangent. Tangent of 80 degrees is opposite over the adjacent side. I don't have the adjacent side. I'm going to multiply by the adjacent and then divide by the tangent of 80. Again, I'm making sure my calculator is in degree mode. 3.5 divided by the tangent of 80 is this 0.62. Then I have this length times this height. 3.1 times 3.8 plus 0.62, and that gives me the 1307, which is this whole thing. Are you okay with that?
You have to minus.
And then you're going to have to subtract off this triangle. 13.7 minus this triangle, which is 1/2 base times height. 1/2 times the 0.62 times the 3.5, and that's in yards, is 1.085. 13.7 minus that answer is going to tell me that the area is 12.6 yards squared. So when you look at that, there's several different ways that you can go about getting the correct answer. You okay with that? Does everyone have that one down? Back page, Herons Formula. Using Herons Formula, we're going to find the area of a triangle, and we use Herons Formula when you have a side, 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 but no angles given. The S stands for semi-perimeter. You add all of the sides together and divide by 2, and that gives you a semi-perimeter. Then the formula is the square root of your semi-perimeter times the difference of each side subtracted from the semi-perimeter. I have side, side, side given. The first thing I'm going to do is I'm going to add all of my sides together and divide by 2. I am going to store, and in the calculator, you store your values, catty corner from 1. I'm going to store the values in X. If I push X, enter, I know that 18.5 is the value of now X. Okay? Then I'm just going to do the square root and type it all in at the same time, but this time I'm going to use the X, which is my 18.5, and then do the perimeter. So X minus 12, close parenthesis, open, X minus 8, close parenthesis, open, X minus 17, close parenthesis, enter, and the area is 43.5. I like using the store because once you get it stored in there, you don't have to type 18 point whatever again and again and again. The area is 43.5 units squared. Okay. Then on the wing, we are doing our Mach 2.3 Delta Dart F106, and we have side, angle, side. Since I'm finding the area of just that wing, I'm going to use 1/2 of 19.2 times 37.6 times the sine of 68. And I'm just typing it all into the calculator at the same time. And the area of that wing is 334.7. If I'm rounding to the nearest square feet, it will be 335 feet squared. Any problems, questions with that one?
We're always gonna be rounding to like.
It'll tell you to round to something, to the nearest foot or to the nearest tenth of a foot or whatever. Just follow the instructions. Ready to move along? All right. We have that surveyor again that is walking a triangular piece of property. They walked 200 feet in the direction of south, 10 degrees east. So when I'm looking at this, I notice that I have my compass drawn. 10 degrees south and east means that 10 is in this little bitty tiny hook right there. And the surveyor walked for 200 feet along this line. They turned and walked north 80 degrees. This entire angle from north is 80 degrees. From north to west is 90 degrees. If I subtract 80 from 90, then this little piece is 10. Parallel lines cut by a transversal, alternating interior angles are the same. If I take 10 degrees from 80, then this inside piece, the angle that I need in my triangle, is 70 degrees. Then the surveyor walked 85 degrees east of north.
Where did you get the number 52?
I am not there yet. I'm not at 52 yet.
So all you know is he just walked.
He's just walking. I'm just reading through the problem, drawing in my lines, putting in the angles that I know. 85 degrees north, 85 east means this is 85 degrees here. From north to east is 90 degrees. So this little piece in here is 5. Parallel lines cut by a transversal tells me that this is 5, which means this is 85, which tells me that 85 and 10 means this entire center angle is 95. Now, I want to know the area of the property. All I have is angle, side, angle. Angle, side, angle means that I can use the law of sines to find another side. I'm going to use my law of sines to find this side. My side in question is opposite the 95 degrees. And I'm going to use the 200 opposite of the 15 degrees. How did I know that that was 15 degrees?
Which one? Oh, because you added the 5.
Yeah, I added the 95 and the 70 and got it, or you could add the 5 and the 10. And you can double check to make sure it all adds up to 180. Then using the law of sines, again, I cross multiplied and divided, and I got that side of 52. Now, you didn't get 52?
I got 700.
Yeah, I also
I
got
did too.
769.
Okay.
Okay, well, 200 divided by the sine of 15
I just
times the sine of 95, 769.8. Is that better? I don't know what I did. Right? You knew something was wrong if 52 was opposite your largest angle. All right. Now I'm going to use my formula for the area given the side. So 1/2, 769.8 times the 200 times the sine of the included angle 70. And that's another reason why you want to check before you start doing calculations, is your calculator in the correct mode? Because that may have, I don't know that that's what happened, but I don't know. Times 1/2 times the sine of 70, and everybody got 72,337. Is that better?
Yes.
337 round to the nearest square foot. That makes more sense for a piece of property.
All these properties are triangular.